the previous video, we did this problem using long division, and it took a really long time. But we're going to do this one using synthetic division. So I'm going to show you guys the textbook way of doing it, and then I'll show you the way I set things up. It's the same process, I just do different drawings. So here's what you usually see in the textbook. You see like a little chair type thing right here. They call it chairs sometimes. Sometimes I wish I had one of these I could put you guys in. Just kidding. All right, now, if this says x minus 2, this is what we're testing to see if this is a factor. Does this go into this evenly or not? Well, we already know that it does, right? So if this says x minus 2, you actually got to put the number 2 right there. This would actually be known as the root of the equation. Now, right now we're going to start out with x cubed, then we're going to go down to x squared, x to the first, and then x to the 0. Then ask yourself, so how many x cubes do we have? And I'm going to say 3. And how many x squareds do we have? Negative 7. And how many x to the firsts? 9. And this is where this constant at the end, that's technically negative 14. You could say x to the 0, because by the way, just in case you're wondering, x to the 0, everybody is just equal to the number 1. Anything to the 0 power is 1. But I'll erase that so I don't want you to get confused. Then a lot of times you'll see in a textbook, you put a big old line right there. All right. The very first process in synthetic division, by the way, you can only use synthetic division if this is to the power of 1. This won't work if it's to the power of 2 or 3. It won't work. What are you going to have to do if it's to the power of 2 or 3? You got to do long division. Sorry. That's the way it is. So the first step is just bring down the number 3. That's it. Pretty easy. Bring down the 3. Then what you're going to do is you're going to take the 3 and you're going to multiply it to the 2 and you're going to put a 6 right there. So what I did, I brought down the 3. Multiplied the 3 times the 2, got a 6. So far, so good? Then you're going to take the negative 7 and the 6, and you're just going to add them together. And if you add them together, you get a negative 1. And then you're going to take the negative 1 and you're going to multiply it to the 2. And you're going to get negative 2. And then you're going to take the 9 and add it to the negative 2, which is just 9 minus 2. What does that give you? 7. And then you're going to take the 2 and multiply it to the 7 and get 14. Then you're going to take the negative 14 and add it to the 14 and get a whole lot of... By the way, everybody, this is your remainder. Sometimes you'll have a remainder, sometimes you won't. Now, how do I interpret this 3, this negative 1, and this 7? Well, here's how it works. If you've got x cubed here, I need you to understand this 3 represents how many x squared you're going to have. This is going to go down by 1, which means it's going to go x to the first. This is how many x to the power of 0. So my final answer is 3x squared minus x plus 7. 3x squared minus an x plus the 7. By the way, let's go back and look at our final answer from our previous problem doing long division. Hey, look. 3x squared minus x plus 7. Got the exact same answer, but this is just a bit faster. Now, this is the way you'll see in a textbook. You don't have to do this in your journal unless you want to. I'm going to do the same exact problem. Oops, there we go. But this is what I do, all right? Basically, I just make my own L the way I feel like it, all right? And I do the exact same thing. I put x cubed, x squared, x to the first, x to 0. I put the 2 over here. I write the exact same numbers down. For some reason, it just works better for me this way. Same concept. All I did is what? Didn't put the little chair and then put one line. All I did was just do down and over. That's all I did. Okay, so when I'm doing it, same process. Multiply together, add your like terms. Multiply together, multiply these together, add your like terms. Multiply these together, add your like terms, you get the exact same answer. Okay? So it's more of a drawing difference than it is a process difference. going to do now, last problem I'm going to do with you right now is I'm going to do problem number 6, because problem number 6 is going to have a remainder. Okay? So right now, what do you do if you have a remainder? So I'm just going to do it the way I like it. All right? If you want to put the little L going that way, that's fine. I'm going to start with my x cubes. Then I'm going to go down to my x squares, my x to the first, and my x to the 0. If this says x minus 4, what number do I have to put right here? Positive 4. That's the main thing. If you see x minus 4, this is going to be a positive 4. That's right. You put, if this was x plus 4, you'd put a negative 4. Very good. How many x cubes do I have? 1. X squared? Good. That's right. So now that you've done that, we do the exact same process. What are we going to bring down, everybody? We're bringing down the... Done. What are we going to do with the 1 and the 4? Multiply. What is that? 4. What are we going to do with the negative 8 and the 4? Add it. What is it? Negative 4. Man. What are we going to do with the negative 4 and the 4? Good. What is it? Negative 16. Add together. 3. What do we do with the 3 and the 4? Multiply. What is it? 12. When we add it together, what do we get? We get a 3. Uh-oh. We have a remainder. Bummer. By the way, there's no I right there. It's kind of hard to see. All right, so there's my remainder. By the way, if we started out with x cubed, what is this number going to be? That's how many what? Very good, x squared. So that's your x squared. This is your x to the first. This is your x to the 0. So my final answer, everybody, is 1x squared minus 4 x's plus 3. Well, what do we have? We have a remainder. So here's how it works. You put, since it's a plus 3, I put plus 3 over, what was our divisor? That's right, our divisor was x minus 4. That was our divisor right there. So whatever the divisor is, everybody, I'm going to highlight something. If you have a remainder, whatever this divisor is will always be what's in the denominator right there. Whatever number that you get for your numerator, whatever you get for your remainder, you just put it in the numerator. Okay? So one quick little thing, what if you got, everybody, what if this was a negative 3? Then you would just say, instead of plus, you would just say minus. But it wasn't a negative 3. It was a positive. All right? So if you're wondering what your final answer is, I want to make sure you know. That right there is your final answer for the quotient of problem 6. Hope this was helpful to you. Have a good day.